These are the GVCs for 9th grade math that you guys requested most you needed to review when you did the 4, 3, 2, 1 self-assessment and identified the different GVCs that you most needed help reviewing or remembering. So copy each example into your notes so you can get the points for your notebook check. The first one that we're going to look at is predicting using the line of best fit. So if we have this scatter plot with a line of best fit, the equation is given to us, y equals 1.86x plus 11.28. We want to be able to predict what would be the cost of money spent in entertainment for a student who works 12 hours by plugging the 12 hours into the equation. We can see that the amount of hours that the student works is the x variable, which means we're going to plug in 12 for x into our equation. We can use the calculator to find the answer. Since we get 33.6, that means the cost would be $33.60. The next question is being able to identify the equation for a graph. So we're going to look at the graph and we're going to use the formula y equals mx plus b, where m stands for the slope of the graph and b stands for the y-intercept of the graph. The y-intercept is the place where our line crosses the y-axis, which is the vertical axis. Since this crosses at the point 0, 1, the y-intercept is 1. We're also going to look at the slope, the rise over run. From one point to the next, it goes down 2 squares and over 1 square. So since it goes down 2 and over 1, written as a fraction, that's negative 2 over 1, simplifying to negative 2 for our slope. The slope number gets the x, the y-intercept number does not get the x, so we get y equals negative 2x plus 1 as the equation for that line. Number 3 is being able to write the inequality for the graph. Now it's exactly the same as before, y equals mx plus b, except we're going to have greater than, less than, greater than or equal to, or less than or equal to instead of that equal sign. But we are going to start by finding the y-intercept and the slope. The y-intercept is where that line, dotted line, crosses the y-axis at the point 3. The slope, since it goes down 4 and over 2 to the next point, is going to be negative 4 over 2, which simplifies to be negative 2. But when we write the equation, y equals negative 2x plus 3, we're going to remove the equal sign and replace it with one of these inequality signs. Let's look at each one. This first one is a greater than sign. For that one, we would have a dotted line and shade above. The next is a less than sign. We would have a dotted line and shade below. For less than or equal to, we would have a solid line and shade below. And for greater than or equal to, we would have a solid line and shade above. Since on our graph it's a dotted line shaded above, we're going to use the greater than symbol. Y is greater than negative 2x plus 3. For number 4, we're going to write the system of inequalities. That's just two inequalities together on the same graph. So we're going to look at them one at a time using the y equals mx plus b equation, but then replacing the equal sign with either greater than, less than, greater than or equal to, or less than or equal to symbols. On this equation, we can see the y-intercept is there at 5. We find another point and see rise over run. This one goes up 6 and over 3. If we find the slope, that would simplify to be 2. So we write the equation with 2x plus 5, although instead of y equaling that, we're going to look at our line. Since it's a dotted line and it's shaded below, we would use the less than symbol. Now let's look at the other line. For the other line, we are going to have our y-intercept at negative 7, and from one point to the next it goes down 6 and over 3. We find our equation by doing rise over run. It goes down 6 and over 3. Negative 6 over 3 simplifies to negative 2. So our slope is negative 2 and our y-intercept is negative 7. And instead of an equal sign, we're going to look at the inequalities. This is a solid line shaded below, so we're going to use the less than or equal to. Those two inequalities together is a system of inequalities that's graphed. For number 5, we want to write the equation again, but this time we've got decimals involved, so we have to use an equation instead of just looking at the graph. We're going to use y equals mx plus b, We'll find the slope by looking for rise over run and simplifying that fraction. However, when we go to find the y-intercept, it's a decimal, and so we can't just look at the y-axis and see where it crosses. We have to actually plug in some numbers and solve. Since our slope is 5 over 3, we can plug that into the equation, but we don't know the y-intercept. What we do now is choose one of the points on our graph on the line. In this case, -2, -6. Remember that the first number is for x and the second number is for y. We're going to plug them into our equation where -6 is the y number, so we plug -6 in for the y spot, and -2 is the x number, so we plug -2 into the x spot in our equation. We leave the plus b because we don't know what the y-intercept is. That is, of course, until we solve it. We're going to multiply 5/3 times -2, then we're going to solve by adding 10/3 to both sides, and we end up finding that b is equal to -8/3. We go back up to our equation, take out the plus b, and write -8/3 to get our equation for the line in the graph. Number 6, we're going to look at the line y equals 2x minus 6 and find the slopes for a line parallel and perpendicular to that line. We're going to use the form y equals mx plus b again. Since we're looking at a slope, we're going to look at the number with the x. In this case, 2 is the slope. Well, a parallel line has to have the same slope, so the slope would be 2 for any line parallel to that one. Part B, we're also going to look at the slope, but a perpendicular line will have to flip the slope and then change the sign. Since in this case our slope started as 2, we're going to flip it. Now a whole number is always over 1 since whole numbers are in the ones place. So we're going to flip 2 over 1, which will become 1/2, and then change the sign, making it -1/2 for the slope of a line perpendicular to the original. Number 7 is going to be having us solve a system of equations using elimination. Elimination means we add the two equations together so that something would cancel. In this case, 2x and -2x will cancel since we add them together and get 0. We're going to add the rest of our like terms, -3y plus 6y and 8 plus -20. Then we can solve the equation by dividing the 3 on both sides and get that y equals -4. We still have to find the value for x, however, so we're going to choose one of the original equations, and this time plug in -4 where the y used to be. So instead of 2x minus 3y equals 8, we'd get 2x minus 3 times -4 equals 8. We would multiply -3 and -4, and then we would solve our equation by subtracting 12 and then dividing by 2 on both sides. Remember that in a coordinate, the x is always first and the y is always second. So to write our answer in coordinate notation, we would have -2, -4, since x is -2 and y is -4. The last one we're going to look at is finding the distance between 2 points. If we have the point H and the point G, we would use the distance formula to find the distance between these 2 points. Remember that the first coordinate is the x number and the second coordinate is the y number. So when we try to find x minus x in our formula, we're going to use 5 minus -1. And when we find y minus y in the formula, we'll have 6 minus -1. Remember that the parentheses are very important in this formula. When we plug this into the calculator, our equation simplifies to be the square root of 85, which is the distance between points G and H.